Wednesday again. There we go. Come on, show that. Nope. All right, cool. Okay, I'm going to fire up NetBeans here. I forget this always takes forever. I should do that first. So if I post the quiz today for chapter 3, does anyone want it early, or do you just want to wait till we finish the chapter on Monday? I can do either.
I'm good waiting. Yeah, I'm good waiting.
Wait, okay.
I
Cool.
don't want to take it when we have to remember it. Stuff.
Okay. Yeah, so yeah, no good point in having it open early then. I get it. All right, so I'll do that on Monday. We'll open up the quiz for chapter 3. I'll have a week and then until 11:59 p.m. the next day, or the next Monday, to take it. And we'll just sort of, that'll be the flow for quizzes. Right after we finish the chapter, I'll post it. You'll have the week plus till the end of the day. So I can remind you the following Monday in case you didn't get a chance to finish that one yet. So our chapter 2 quiz should be due, I think, on the 20th then. Yeah, the 20th, 11:59 p.m. Yeah, it's just 10 questions out of the question bank. The short answers are terrible. Apologize. So I think I fixed most of them for you for chapter 1 if you had any issues. Just a reminder to go look, go check that out and make sure it didn't mark you down for anything that it shouldn't have. This here. All right. And then I have the PowerPoint slides out here in content for you folks, if you like that sort of thing. I hate when people read PowerPoint to me, so I'm not going to like show you PowerPoint and read it to you. And then, usually as soon as something goes up on the screen, you're reading that anyway and not listening. We're all bad multitaskers, despite us pretending like we are good ones. So I'm just going to go over stuff in NetBeans and show you examples. I'm still kind of go like topic by topic through it, and we'll follow that same order. But my goal is to give you different examples than what the book has, so like you'll see it 2 different ways, right? And then if you need another way, we can find more things online. It's no fun to have me tell you the same thing and then go read it. I find that just really bores people, and then you're even less likely to go read the textbook. So that's it. All right, so I'm going to start up a new project. I already have a chapter 3 project from the Tuesday night class, because they're ahead of us now. So we did all of chapter 3 Tuesday night. We're going to do half of chapter 3 tonight, half of chapter 3 the following Monday. So if you go look for the code, I'm going to try and tag all of our stuff with morning. This will be chapter 3 morning or something. So just know if you're going to go look in the course GitHub repository, our stuff will be tagged with the morning. I didn't do that with the chapter 2 examples, but we ended up sharing them because power outage and whatnot. But generally that'll be the flow. So we'll have separate code in our course repository instead of keeping 2 different ones. I think this will be a little easier, and that way you can see other examples too if you want to see the code there. Hey Michael, thanks for hanging out online. All right, should be able to find Twitch chat here. So I like deleting all these comments. You can go change all of that in the settings, and I always mean to go do it, and I forget. So every time I start a project, I'm just going to delete those comments out. Everything we're doing is starting inside of this public static void main string args, or string square brace args. Remember, we find those curly braces, and all of our code's going to go inside here to start. So we can just get rid of that to do. Maybe put a couple blank lines in there so we have some space to start doing all of our commands. And again, I'll just make sure it'll run for me real quick. Hello world, happy Wednesday. And make sure that gives me a run. Because every so often I get this issue with my compile on save setting where nothing actually runs. I think I just have bad luck with NetBeans. Yep, so it says it ran and nothing happened. So if you're getting that, you go to your project and right click on it and go to properties. And then under compiling, you want to uncheck this compile on save. Usually it works. It used to work for me. I have no idea what changed. Uncheck that, and then when you actually run, it'll actually build, and you can run your Java code, and life should be good. Now I get my hello world, happy Wednesday. And just a real quick, make sure that it's running for you, so you don't run into anything else later. Yeah, Michael, the system.out.println, that's a little bit long. Other languages, you don't necessarily have to type quite as much. But at least you have shortcuts, right? So, and don't type things out by hand if you don't need to. I mean, SOUT and then tab will autocomplete that for you. I'm a big fan of shortcuts. Or just, grab the line and copy paste it. If you want to do a bunch of prints, any of those work fine for you. All right. So in Java, there are 8 different, we'll call primitive types that we're going to work with. So primitive types are where we're actually storing the value right in memory. Remember, when we run our Java code, the Java virtual machine asks the operating system for places to store stuff in memory. So if we say, hey, I want an integer for my number, it's 42, your operating system is going to go out, or your Java virtual machine will go out and ask the operating system, say, hey, I need a place to store this number, and this actually takes up 4 bytes. So in 4 bytes, right, each byte being 8 bits, we're going to go store the number 42. Remember, we looked at this little bit calculator, which is a lot of fun on the Windows calculator. It's actually really handy. I really like this tool. In the programmer mode, if you go to binary, you can do the bit entering. Remember we did this? Does that ring any bells? You didn't do this? Where you can click the numbers? We didn't do this? I'm going. Yeah, from the
That Wednesday.
Yeah, the Wednesday where I didn't have power, so I couldn't do it from home.
Yeah, that was wrong.
Okay, good. All right, I'm not going crazy. Thank you. So make sure you check out that recording. But you can check out the individual bits here if you flip them on and off and see what the values are. So the 32nd bit here is worth, or has the value of 2,147,483,648. So if you add up all the other bits, which is a bunch of clicking, but you'll get 1 less than that. So Java will use 31 of the 32 bits to store your value, and then 1 of the bits to indicate whether or not it's positive or negative. That's why the maximum value for an integer is 2,147,483,647. And no, I don't have that memorized. It's right here on my screen. Okay, right, don't memorize stuff like that. It's just a waste of your brain power. But it takes 4 bytes of memory to store this thing. If you need a number bigger than 2 billion something, you have an option to use something called a long. But long is a longer integer. This is a bigger number. This can get up to something ridiculously large. What is this? Millions, billions, trillions, quadrillions, 9 centillions is like the maximum for a long. That's a really big number. Sure, so let's just do, like, say, 123 billion. And remember, you can use underscores in your numbers as a digit separator. This is super cool because sometimes it's really hard to see what these values are. So if I just start entering, that's 123 million, we go to billion. If I want it to be a long value, I throw in an L there. Now, I'm not a big fan of this font because I get really confused easily. It looks a whole lot like a 1 to me, but technically that 1 is a little bit slanted at the top there. It's real awkward looking. So that's an L, not a 1. I mean, you'll see that it's a type of long, so hopefully that's a little clue that it's not a 1 over there. And then again, it doesn't really fit the digit grouping. So this is 123 billion. This still integer values, right, but it takes up 8 bytes. So we get, for every one of those values, we're using 8 bytes here. So remember, a group of 8 bits is a byte. So it's 1, here's 2, 3, 4, 5, 6, 7, 8. So this last bit here is my maximum value. Oh, look at that, it's even screwy here. It thinks it's negative number. I don't even know why it thinks it's negative. That's super weird. Maybe it's confused too. But 9 centillion or so, using 63 of the bytes, leaving 1 to indicate positive or negative. And it's all interesting. It's all well and good. Not too big of a deal. Just go look it up in the table. Now, if you want to get fancy and you say, hey, I really want to make sure that I'm using the least amount of memory possible, which I'm not going to ask you to do. It's our first programming course. Just know that this exists. And if you're going to do anything at like million times scale, this matters. For us here, even if we have like thousands of these, our computer has billions of bytes of memory. So every kilobyte of memory is 1,000 bytes. Every megabyte is 1,000,000 bytes. Every gigabyte is 1,000,000,000 bytes. So if your computer has like 8 gigabytes of RAM, you have 8 billion bytes of memory that you can use. Now, I know Windows and other processes use up a bunch of them, but that's essentially our excuse to be lazy, right? Even if we have like 50 different numbers, I don't care if you're using up 4 bytes versus 8 bytes, right? Times 50, what are we getting here? Like 200 bytes out of our 2 billion? No one really cares, right? So we have the luxury of being essentially lazy and saying, just fine, I put everything in as an int. I don't care if I'm not going to get up to 2 billion. But if you want to, you can use a value called a short. So a short is only going to use 2 bytes of memory. So these are for small numbers. So you can get up to, it's about 32,000 or so here. And again, a little bit because this one uses 2 bytes. 2 bytes of memory. Did I close my calculator down? Come on. So in 2 bytes of memory, it's only going to use 16 bits here. So the value of that last one, 32,000, is 1 less than that for the first 15 bits, and then 1 bit to indicate positive or negative. So smaller numbers will fit in shorts. If you want to use them because you're fancy, have at it. I'm not going to ask you. Again, I'm pretty much going to stick to integers because they're easy. If we need more than 2 billion, then we have to look at maybe a long. So this one's nice. You don't have to tell Java that it's short. You don't have to put an S in or something silly to tell it it's a short. It just knows, hey, it fits. But it's also smart. If you try and give it too big of a number here, it's going to yell at us. If we get bigger than that maximum value, it says possible lossy conversion from int to short. So it does know that, hey, you gave me something that's not a short. It's not going to fit over here. And it's not even going to compile here. We're getting a nice big red error here. So it's smart if you have a value that is literally in your code. But if I'm just asking for user input saying, hey, can you enter a number, please? And I try and save it in a short and the user types in 300,000, it's not going to work. Right? We got bad news bears. Even more than that, if you want to get fancy, you can use a byte value. A really small number. This one can only go up to 127. It's only using 1 byte of memory. Close the calculator again. I didn't just like leave it behind. So with a single byte, right, just 8 bits here, the max, the 8th bit here, 128. That means we get 7 bits for our value up to 127, and then 1 byte for positive or negative. Okay? I just closed it again. Wow. And that, as you guessed, probably takes up 1 byte of memory. So yes, if you're doing something like with 1,000,000 integer values, and they're all really small integer values, sure, using a byte would save a lot of space, right? If we have exactly 1,000,000, that saves 3 million bytes. That's a pretty good, savings if we have 1,000,000 values. We're not going to do anything with 1,000,000 values in this course. Right? Later on, if you continue on, you'll take an algorithms and analysis course. That's when you start to care. And you say, well, how much space does it actually take, and can we do better? And that's part of the science of programming, when we actually spend the time to say, can we do better than this? Because, yeah, that is nice and important, but if I have, again, 10 values, I don't really care if I can reduce the size of those 10. No one's going to care because we have billions. It also, the programming, just as a profession, has gotten a little bit lazy because it's so easy to send updates out. I don't know if you folks remember, you used to be able to buy software and it would come on a CD. I'm not that old, right? You guys know what CDs are? It's going to happen someday, which is going to blow my mind. So if you had to physically manufacture a CD and give it to someone with your software on it, and you had to make a change because you screwed up somewhere, that's really expensive, right? But nowadays, you push out your change online and it updates itself, and oh, sure, great. So we've gotten a little bit lazy. You know, being lazy about using memory is a little bit different than like having bugs in your code. But again, you know, life has gotten easier for us. Computers have gotten faster, more powerful. The internet's wonderful, and we can send updates out. So unfortunately, we've gotten a little bit lazy, you know, and not in the good way that we want to be efficient either. So, all right, so all of these are dealing with integers or whole numbers. When we deal with numbers with decimal places, we talked about usually we're going to use a double, right? So a double here. So this is a number with a decimal, right? It's like 7.7. Sure, these can get relatively large, and a double can have up to 16 significant digits. So you can have a lot of decimal places, right? What's cool, I saw this article, was it how many digits of pi do you need to land on the moon, essentially? There's this really cool article from the Jet Propulsion Lab at NASA saying, how many digits of pi do we really need? Do I need, you know, 15 digits of pi? And essentially, they said, hey, for our Voyager 1 mission, 12.5 billion miles away, we only need 15 decimal places of pi, and that will get us within 1.5 inches of where we were going with our calculations. 12 billion miles away, right? So anything close, right? The moon's not 12 billion miles away, right? What was it? That's like 80,000 or something, isn't it? The moon. Oh, 230,000. We're not going to need that many digits of pi to get to the moon. Right? Just like in the scale of things, that's a lot of decimal places. Okay? You guys don't seem as impressed with that fact. It's okay. So doubles can have a lot of decimal places, a lot of precision, and a double takes up 8 bytes of storage, which is pretty cool. So the way that it stores it, it has to tell Java how many decimal places it has and how large it is. There's like an integer portion, and then there's the decimal portion. It does some really cool stuff. You can learn more about that if you want to continue on. You'll probably learn about that in like a computer organization or assembly class. So yeah. And we talked about floats back in chapter 2. So a float is essentially a smaller number with a decimal place. So this is smaller number with a decimal. Now, again, for a float, the reason why I hate them and I never use them, if you want a floating point value, like let's do 920.7, you have to add the letter F to tell Java, yes, I want a float. If you don't add that, we're going to get that error saying possible lossy conversion from double to float. Saying what Java treats numbers of decimal places as the literals in our code, they treats them as doubles. So if we want to actually use the float, we have to add the F here to tell Java, yes, it really is a floating point number. I don't have 15 decimal places or more than, a float can have up to 7 decimal places. You'd think it could just figure that out, but it's not all that smart, unfortunately. So this takes up 4 bytes of memory. That's pretty good. Right? So again, if you're not using really, really large ones, this is a good thing to do eventually, but we don't care too much. So that's it for the numbers with decimal places. So 4 different types for integer values, 2 different types for numbers with decimal places. And again, we're just going to use doubles all the time because we're lazy, and it's not going to matter because we're not doing millions of anything. Okay. 2 other types that are really cool is the char type. Char is short for character. So this is a single character. Now with characters, it's not a double quote like a string. Remember, we use double quotes for strings, which is a bunch of characters. A single character, we're going to use the apostrophes or single quotes here to represent a single character. And that can be any letter, any number, any special character like the curly brace or like a pipe. Pipe's a really fun character. Sure. That's the shift backslash is the pipe character. This one's really fun. When we store characters, we're actually storing, this takes up 2 bytes of memory, we're storing a 2-byte integer value. So there's this thing called Unicode or ASCII. So if you look up the ASCII table, it's a mapping of integer values, ASCIItable.com, look at that. Integer values to a character. So there's a bunch of like really special ones that I don't even know what most of these ones are, but we care like about 32 or so. It's the space character. So when we're storing the actual characters, every character takes 2 bytes of memory in Java that we're storing. So if I wanted to write out my name, right, Eric here, I see the capital E is a 69 value in decimal. There's also hexadecimal, octal, HTML encoding. Don't worry about those for now. So the decimal value is 69. So you can give it the character value, or you can say, hey, here's a char. This is a capital E is 69. Just give it the numeric value. I don't recommend this, but you know, if you do this, you're going to look fancy, I guess, if you're trying to impress people. I guess I'm trying to impress you by writing out my name here in decimal values. Okay. It's just a fun illustration. So I find capital E, and I want to find a lowercase r. So lowercase r is 114. And then a char for lowercase I. Probably lowercase I is going to be 105. And then a lowercase c is going to be, is that 99? 99. So if I wanted to print out individual characters, right, I could say, hey, I want the capital E plus the lowercase r plus the lowercase I plus the lowercase c. Here, let me bump that down a line so you can see it all in one print here. Right, so I can say, hey, take all my characters, smash them together, let's print them out here. Right, see if I can get Eric one character at a time. Uh-oh, 387, that's not a character. Remember, because we're storing actual numeric values, if you tell Java adds a bunch of numeric values together, it'll add them together. Right, if I do a single one here though, and then I print out one at a time, it's going to be a little smarter. Because now there's no arithmetic happening. It's saying, hey, print out one character at a time. So if I print out one at a time, oops, a little format. Come on, get rid of that.
Why does that not work when you like concatenate them?
So
together?
the addition operator, if you take a string and a string, will concatenate, stick them together. But characters are actually numeric values. So Java said, oh, you want to take 69 plus 114 plus 105 plus 99. That's 387. It says, I'll do the math for you.
But I thought
Maybe.
it doesn't like convert them to the characters first.
Nope. So it's a little silly, a little bit dumb. But, I mean, when it sees a bunch of numeric values and it sees a plus sign, it thinks addition, not concatenation. So even though it's a character type, what it's seeing behind the scenes is the numeric values. If you print out just one of them, it's going to turn it into a string automatically.
It's weird.
It is. So just be careful using characters. Again, we're probably not going to use an individual character very often, but just know they're actually numeric values behind the scenes, so weird stuff can happen. Now, if you've actually read in the text, there are other print commands, not just print line, right? There's a print command, which does not give you a new line. It doesn't go down a line. So if I print, and then print line on the last one, they're all going to be on the same line. I'm not a big fan of print, but sure. So now I get Eric, printing out one character at a time. Super fun. All right, the last primitive type. And again, primitives, these are different than objects. We'll get into more about what objects mean later, but these ones, we're storing the actual value directly in memory here. It'll mean more later. Just keep that there. It's the type of Boolean. So Boolean is a single bit, just on or off, true or false, yes or no. That's all it can be. Typically we give it true or false. You can give it 0 or 1 and it knows that means true or false, but again, the code we write is for people. So if you're going to tell it true or false, just write out true or false so you can see that in the code and don't have to remember 1 is true and 0 is false. It's not the hardest thing in the world to remember, but again, you don't have to be fancy. You're not trying to impress anybody. We're just trying to write code we can read. So if I have a Boolean value like, are you hungry? I can say equals true. I just give it the word true. You notice it turns orange. It's this one of these Java reserved words. I can't use this name true anywhere else. It means something special to Java. So anything that shows up one of those colors, it's a reserved word. Right, there's that whole table in the book of things we can't use. So Boolean is just true or false. Now, when we looked at chapter 2, we having like if statements. We said, hey, you have to give it a Boolean expression. Like, does this equal this? Does this not equal this? Is this greater than this? That sort of thing. You can also just give it a Boolean value. You can say, if, are you hungry? Print, go eat. Else, I don't know, there is free food at noon on campus. Right? Maybe you want to reconsider if you're hungry or not. Because if there's free food, maybe you just want to go eat it anyway. And who turns down free food, right? So this is just a Boolean value. It's not a Boolean expression. I'm not saying, does this equal this? And it just says, hey, if it's true, go for it. If it's false, go for it. Now, a lot of times I see people say, if they have a Boolean value, they'll say, hey, if this equals true. This is technically fine, but it really irritates me because, again, it's not lazy. Like, this already is true or false. You don't need to say, does true equal true? If true equals true, do something. Right? Because already you just say, hey, if it's true, do this. You don't need to say, does true equal true? Now, if you wanted to, you could say, like, does not equal true. And then if it's not true, this would run. That's a little awkward. Maybe you just flip your if and your else then. Right? It works, but it's going to be a little bit awkward to read and to follow to say, okay, so if are you hungry is not true, that means are you hungry must be false for this block to be true for this to run. Like, it's not wrong, it's just awkward to read and to follow. So if you have to look at your code and like it feels funny, and again, that's part of the art of coding, right? If it looks a little weird and it's hard to follow, maybe we did something wrong here. So you can do the easiest thing to do and just say, yes, if this is true, run my if block. Remember, everything inside the set of curly braces run. If it's not true, it means it's false, and then everything inside the else block will run. So an individual Boolean or the Boolean expression, just don't say, does true equal true? Because you've just taken more time. Yeah, so if you don't have an else, yeah, you might say, if it doesn't equal true. Now, it's the easier way to write that. So if you want to say, okay, we only care about if you're like, are you hungry does not equal true, right? If that's false, essentially, right? Saying not true is a little awkward. You might just say then, if it equals false, right? This is nice and clear, right? If are you hungry is false, do something. The other way to write that is using the not operator. Remember, the exclamation mark is not. So not are you hungry is how you'd commonly write this. So this is true or false. Not that is the opposite. So if are you hungry is true, not true is false. Not false is true. Right? Because not will flip it one direction or the other. So this is more what you'd see if you wanted to say, hey, does it equal false, rather than if it equals false. And nothing wrong with this one. And this one's nice and clear, because sometimes we get confused about what the exclamation mark means. But this is generally pretty common here. Not are you hungry, instead of if it equals false. But either one's fine. You can go either direction. Yeah, I mean, so you're saying not, but you don't know what the value of this is, Lesket? Like, so I might ask them, like, say, hey, enter yes if you're hungry or something, and I can check, and then I would set the value. So I'm probably not going to put a literal in my code and say true, and then go check if it's true or not. Like, more likely I would ask them, hey, enter yes if you're hungry, enter no if you're not hungry, and I could go set the value based on whatever they gave me. Right, so I don't really know what the value is going to be. So then, not hungry, yes hungry, just depends. But Booleans are fantastic. These are great values to use. We will use these not all the time, but they're very common. So chars, probably not very often, because strings are just easier most of the time. So ints for integers, for whole numbers, doubles for numbers with decimal places, and Booleans for yes, no, true, falses. Those are going to be our three most common that we're going to use. Now you'll notice string is not in this list. String is not a primitive type in Java. Right? If you have a string, like name, notice it's a capital here. All the primitives are lower cases. So string here is actually a class in Java. So it's a class. When you have strings, you have objects, is our technical term for that. So we're dealing with objects when we talk about strings, not primitives. So there's objects and then there's primitives. That's really, everything is either an object or a primitive when we get down to it. So this is not a primitive. Primitive? Okay, sure. All right, that was one PowerPoint slide. Oh my goodness. The rest of it goes a lot faster though. This is just a lot of information. Assigning values, yep, great. Now, a couple things you can do. So far we've said, hey, here's my value, here's my variable, right? Here's the type, here's my name for it, and I assign it a value, right? It's not really the equals sign, it's not an equals operator, where this is the assignment operator. We're saying its value is 42. It takes the thing on the right, assigns it to the left, to the variable on the left. You don't have to give it a value right away, right? We could say, hey, I want a integer for favorite number, semicolon. That's it. So we have declared the variable here. We haven't assigned it a value. We just told Java to ask the operating system for a place to store this value. So when we declare it, it'll go out and ask the operating system, hey, where can I put an integer? Remember, the Java virtual machine will ask the operating system will say, here's a place in memory, a memory address. We don't care, somewhere. We haven't used it yet though, but it's reserved for us. We've declared the variable. So this is declaring. Then we can go assign it later. So I might say, hey, what's your favorite number? And then we'll use the scanner. And notice scanner capital S. Again, this is an object. Scanner is a class. So we're going to make an instance of that class to have an object. I like to call it keyboard. The book uses SC. I think SC is a terrible variable name. So I'm going to try and not use it. It's not wrong. It's just, I don't know. New scanner given system.in. And then my favorite number can be the integer.parseInt, parseInt of the keyboard.next line. Right? Again, always a fan of using next line and then doing these conversions with parsing. Scanner can give you integers directly, but the problem with it is if then you want to go read a string out, the enter key, right, is actually a character, right? If we look at that ASCII table, the where is it here? It's one of these ones. Carriage return is value 13. The carriage return says go down a line. There's carriage returns and there's line feeds. That's also a 10. I can never, maybe it's line. Sometimes you use both. Windows likes one and Unix likes the other. I can never remember. I always go look it up. But one of these two, right, says go down a line. Those are not numbers. So when you type in a number like 13 and hit enter, scanner is only grabbing the 1 and 3 and it's leaving that new line character there. So the next time you ask for the next line, it says, oh, hey, I found a character. It's a new line. And that's all you get. So it's not going to give you the values that you want because it's just going to read that new line off the stores it in a buffer as you type it. So using next line and then converting, I think it's always preferable. All right, and I got to add my import for scanner. Great. So I've declared it. This is assigning it. Assign the value. So you can declare things first and then you can assign them later. Perfectly fine. Some people think the best way to write your code is to take all of the variables you're going to use and declare them at the very top. That's one style convention. So like you'd reserve this whole top block here to say, here's my favorite number, here's a variable for name, here's a string variable for your favorite color, here's an integer for this, here's a double for that. Just declare everything at the top and then go use it. Yeah? So if we're following topic by topic from the book, I'm generally trying to give you other examples so that you'll see it one way and then read the book a second way. Things like what a byte is and the size of it. I mean, literally, this is the only size, so like that's not new. But we're going topic by topic, trying to give other examples is the goal. Yep. So if you want to declare everything at the beginning, that's all fine, well and good. I feel like it's more work because then you just have to write them all first and then you go use them. The positive side of that is that it means you've actually thought out what your program needs to do. You've thought ahead to say, okay, these are all the values I'm going to need to store. Hey, I need to know how many guests are coming to the party. Here's an integer. I don't have to give it a value yet, but I know I will need an integer for how many guests. Hey, I'm going to need an integer for how many slices of pie people eat on average. I have an integer for that. I haven't assigned it a value, but I'm saying I need these values to do all my arithmetic. Hey, I'm going to have a total number of slices of pie required, integer. Sure, we could declare it, and then we can go assign it later once we actually have values. So if you've thought through your program, you should be able to define them all first, instead of, you just start defining them anywhere you're using them. I'm partial to this system, but it's nice to be able to define them all up front. Okay. Now, what you don't want to do, right? You don't want to say int, average number of slices of pie here equals, or just declare it here, and then you don't want to leave a comment and say this is average number of slices of pie. If you have to leave a comment telling me what a variable is, you've done a bad thing, right? All you have to do is name your variable better, right? We could have an int average number of slices of pie. Right? Now I don't need a comment telling you it's the average number of slices of pie, because that's literally what the variable is called. Okay? So if you name your variables well, you don't have to tell someone what it means. That's sort of the goal here. It doesn't always work in practice, but almost all the time you can name things well so you don't have to leave comments. This is the thing I lost a point for back when I was an undergrad years and years and years and years ago. And I said, that's so stupid, my program works fine. Why do I have to tell you what it is? So I swore I would never ask people for comments. I've taken it probably to an extreme. There's nothing wrong with comments, but the general idea here is that if you have to leave a comment, you've not done something cleanly and clearly in your code. That's not all the time. There are very good cases for comments. We'll look at some more later, especially around documentation. There's a really cool format you can do for comments. We'll talk about that when we get there. But in general, don't do stupid abbreviations, because you might know what it means like while you're sitting there. You come back a couple hours later or the next day or a week later and you look at it. I don't know what an ANSOP is, ANOSOP. That means nothing, right? Now, you probably don't want to go too crazy. Like, this is the average number of slices of pie a guest will eat at my party. Java doesn't care if you go nuts. That's a little bit long though, right? Like, try and find that happy middle, right? Enough meaning here. Sure, and again, you don't have to type it, right? As you're going to use it, just start typing a couple characters and then tab to autocomplete. Use the tool, let the tool do the typing for you. You could say, hey, it's 17 slices of pie, because people love pie. I mean, I ate half a pie the other night when my mother-in-law made pie. It was really good. It was a chocolate graham cracker bottom with like a whipped cream center. I forget exactly what it was. And then like, it was actually jam on top. I don't know. It was really good though. I ate a ton of it. It's really bad for my diabetes. But so again, probably not quite so long, and you can do better, but not this. So don't leave comments. I mean, what a variable is. Use a better name. Okay, that's the whole story. Crow, I don't know if it makes, I don't think the code's any slower to allocate everything at the top to say, here's all my variables. We're not going to notice a difference asking for a bunch of memory. Not a big deal. All right, so those are our primitive types. We can assign them separately from declaring them. You can also change the value later. I can say, oh, no, actually your favorite number is 42, right? This is not declaring it again. Java already knows I have an integer for favorite number. It's just changing the value. It's assigning it a new value. So a variable can have different values, but it only ever gets to hold one at a time. So you could change it like 50 different times in your code. Like, hey, guess a number, and then change the value of the number that they guess, right? I think we did that with our little guessing game. Here's guess, and then ask them again. Here's guess, ask them again. Here's guess, too high, too low. We're just changing the value here. So you can assign it over and over and over, but it only gets one value at a time. Right, for numeric values, you can use scientific notation if you like it. If you're dealing with really big numbers or lots of decimal places, I'm not a fan of scientific notation because it always confuses me. So I'm not going to use it. Just if you need to, sure, you can. Another thing some people do that I personally find obnoxious, purely because it's just a little bit weirder to read. You can say, hey, I want an int for first equals 5, comma, second equals 10. This is perfectly legitimate Java code. I just find it awkward. So you said the type is integer. Now I have two different integers I've declared and assigned on the same line. Just use more than one line, people, right? Like, it's, just reading it here, you're gonna like kind of pause for a second and be like, second is 10. Oh yeah, it's an int. So generally, I frown upon that. This is the same thing here. So if I said first equals 5, comma, second equals 10, I've done the same thing here. So I'm going to leave this one commented so that it's fine. So it's the same as above. They both do the same thing. I just do one variable per line. I don't know. I just like it that way. For our naming conventions, again, all lowercase for the first word, and then every next word gets a capital letter so that it's easy to see what the next word is. That's that camel casing when we name our variables. You can use numbers. You can use the underscore or the $sign, but no other special characters. You can't have the first character be a number, though. So if you're going to use numbers, they have to come after the start. So it has to be a letter or an underscore to start. Just some silly, those are actual rules in Java. It's not even like a convention. You just can't name it something. So if I have a bunch of values, I can't say like one value equals something. It's going to yell at me. No good here. You know, can't say one value is 10. But I could say value 1 equals 10, int value 2, on and on and on, right? 20, whatever it happens to be. Right? So you can't start with a number, but you can include numbers if you want. Right? Another cool thing you can do, if you have a value that's not supposed to change ever, or it's a value that has like a particular meaning for you, you can declare it in a way that means it can't be changed to protect yourself from changing it by mistake. Because, you know, sometimes things happen and we put the equal sign in the wrong place or we're not really paying attention. So you can declare a value as a final here, which is saying it's a constant value. I'm going to set it once and it's stuck. So if I have a final int for, we'll call it like magic number, equals 42. Now with finals or constants, we put them in all uppercase to make like, hey, this is something special, instead of a regular variable with lowercase values here. And because it's all uppercase, you can't do that camel casing, so it's really hard to tell when one word stops and the next word starts. So we use underscores to separate them. So like magic number here. So then I can do my little guessing game. I can say like while guess does not equal the magic number. Magic number. Nope. Magic number. There we go. Right, I need an int for guess. Keyboard dot next line. Needs a integer dot parse int of the keyboard next line. I will tell them guess a number. 1 to 100 or something like that, right? So like now my loop here actually looks a lot nicer because I have the variable name here of magic number, right? Instead of just having a 42 in my code, and when I come back to it, what does 42 mean? We'll say, oh, it's the magic number here that we're trying to guess, or something like that. Like whatever variable name you're using, you can declare it, and then we have a name for it. So a good rule of thumb is anytime you have a number in your code, like if you're comparing something in an expression, you want to give it a value. If it's a constant value, never changes, make it final. Right? If it's going to change, we'll look at how we could do this guessing game with random numbers eventually. Then it can't be final because we want it to change every time. We want to assign it randomly. That's okay. But in this case, sure, if it's always 42, let's give it a nice name here so that when later on when you see it in my code, it stands out. Right? It's putting a nice name to it. We can close that door if it's too loud. I'm sorry. Yeah, so you can't. I think actually you can declare it final, and then you get to assign it one time. And then you can't assign it. So if I try and assign it a second time, like, hey, it's 43, it's going to yell at me. Say, variable magic number might already have been assigned. Might is a really funny word there because the compiler knows it already was, but sometimes the errors aren't fantastic. So it's going to fail. So you can declare it and then assign it later if you want, sure. But you can't assign it twice. Can't change it once it's been assigned. Okay, and again, this was, as long as it's not there, just say something silly, guess again. We're not even going to tell them too high, too low. Now, every time you have a while loop, you want to make sure that whatever you're comparing here is going to change. If it can't change, your loop is going to be an infinite loop and run forever. Over and over and over and over and over again. Because if we can never change guess, it's always going to be not the number if we guessed it wrong. So make sure in your while loops, you are changing that value. So again, I don't need to tell Java it's an int again. I just say, hey, guess equals this. And we'll just guess and guess and guess and guess over and over and over and over. Eventually, we have a chance of changing guess to the correct thing, where this is no longer true. Right? If it is equal to the magic number, this is false, and the while loop will stop. So again, we're skipping that too high, too low right now, just for the quick example. Right? So these the term here is really awkward. These are called binary operators. Everything we've done in math is a binary operator. It takes something on the right and something on the left, or something on your left, something on your right. I'm always backwards here, and does the operation with them, like 2 plus 4, right? 2 is an operand, 4 is an operand. The addition is the operator, right? So binary means there's two things being operated on. Sure, so int sum equals, we'll say first number plus second number. Right? Didn't I have first number? Oh, I had first and second, sorry. First and second. Sure. This is the addition operator. This is one operand. This is another operand. So there are two things being operated on. Crazy technical terms, right? So you can add, you can subtract, you can multiply, you can divide. There's an additional operator, which is really cool, called modulus, which gives you the remainder. So if you think back to, this was probably like 3rd or 4th grade math class. Your teacher might have gone through this example with 9s because it's really cool. So we'll say enter a value 1 to 9. You have an int for the value is, I'm just going to go copy paste this because I'm lazy. Sure. So if I want to multiply this value, so I'm going to say int, we can make it a brand new number if we want, or we can just change the value. Either one's fine. I'm going to make a new one here. So this is my new value is going to be value times 9. Okay, so take whatever you entered, multiply it by 9. And that's my new value. Then I want to get the value of the tens place. Right? What number is in the tens place? How many tens do you have here? So I'll say to the tens place is equal to, well, to find out what value is in the tens place, what we need to do is divide by 10. I'll take new value, divide it by 10. Remember, when you do integer division, you lose any decimal places. So if new value is an integer, and this is an integer, I'm only going to get the integer result. So if your number is, if the new value is 27, I'm going to get 2. Right? The decimal remainder just gets truncated, gone. It's not there. Okay, so this will give me the tens place if I divide by 10. To get the ones place, I want the remainder. I want to divide by 10 and take what's left over, the integer remainder. I take new value, that's modulus, 10. Modulus is the percent sign, which also is a division operator, depending on what kind of math class you took instead of just the slash. This always confuses people if you're really big into math notation. But percent sign here is modulus. That's modulus. It's the integer remainder of the division. That should probably go on the line above, shouldn't it? not an ints. That's a single int. So the ones place here, divide out all the tens, tell me what's left over. So if I had 27 divided by 10, I have a remainder of 7. So this is the remainder. Like this is what you did long division for when you dealt with remainders, before you figured out how you could just add decimal places. Right? Everyone loves long division in 3rd grade. We're taking you way back here, right? This is your remainder. But now I have the tens place and the ones place. Now what you can do, again, thinking back to this math example here, hopefully, you'll get a int sum of ones, or I don't know, tens and ones place is equal to tens place plus the ones place. You guys know what this is going to be? What the sum's going to be? Or tens place and ones place is, maybe bump that down a line, getting a little long here. Goodness, that's still long. Okay, we'll go there. Do you know what this value is always going to be? 9. Right? If you multiply a number by 9 and then add up the sum of its digits, it's 9. Every time. It's really cool. 9s are really neat, just mathematically. It works with 3-digit numbers and 4-digit numbers and 5-digit numbers, but you have to do the additional summing of the digits again. So like if you have a 3-digit result, you have to sum those digits again to get another number, and then that number summed up will be 9. Right? So you're going to get like multiples of 9. 9s are really neat. Okay, so this is the magic 9. So if we run it, let's double check it. So throw me out a number between 1 and 9. I'll throw in and we'll test it out here.
3.
3, all right. 3, 3. Oh, we have to guess the magic number. It's 42. All right, value 3. Sum of the tens place and ones place is 9. So, okay, so it's your number times 9. Tens place and ones place. I don't know if that makes a lot of sense, but you hopefully you follow what I'm saying. Multiply your number by 9, add up the tens place and the ones place. It's magic. You'll get 9 again. So that's the modulus operator. Modulus is fantastic. Okay. Those are all our binary operators. All right, cool. The last thing we're going to look at, and then I think we'll probably call it a day. We're about halfway through here. We don't want to do too much. We don't have time for practice. Is a unary operator. So a binary operator takes 2 things and operates on them. A unary operator takes 1 thing. So I can take value, and I can say, hey, let's change the value of value. Let's take what value used to be, and let's add 1 to it. So value equals value plus 1. Sure, take the old value. So everything on the right happens first. So take the current value of value, whatever number you entered, add 1 to it, and then assign it back on top of value. Sure. Right, we could do that. No problem here. So we're just going to add 1 to whatever you entered. The shorter way of doing that is with the unary operator. I can take value plus plus. This is my shortcut for add 1. Now this one is the postfix operator for adding 1. Technically, it will use the value first and then add 1 to it. So if you throw this in a print line here, so current value of value here, and then we use the postfix operator. We'll take value plus plus here. Put that note down here. It's going to give me the current value of value in the print line, then it will add 1 to it. So it's not going to look like it changes at all here. So it's going to be the same here in a second. Let's give it a bunch of numbers. 42, 42, 42. Right, current value is 43 because we added 1 to it up here. Current value is still 43. We did plus plus, but because it's a postfix, it happens after we've taken the value. So we get the value first, then add 1. There's also a prefix operator here. You can say plus plus value. This is the opposite. It adds 1 and then gives you the value. Then gives the value. For a prefix operator here. And we're all about shortcuts. So, prefix. So if I take the value, and then I take the value again, then I add 1, and then I add 1 and then give you the value, right? The difference between these ones is going to be 2, because we've added 1 after we used it, and then we added 1 before we used it. Right, so if I give it 42 for my value, we're going to see it jump 2. 42, 42. Yep. See, 42 times 9 is 45. If you sum 4 and 5 again, right, you just have to keep on summing those. Sure. So 43, and then plus 1 puts it at 44. 44 plus 1 gives me 45. So before and after. So those are your shortcuts. You can also do minus minus. Right? We'll take down by 1. We'll subtract. A negative value, we can say like value equals negative value. This negative is technically a unary operator. It operates on one value. It gives you the negative. Right? It works the same way as it does in math class, but you do value on the right gets assigned to the value on the left. So now we flipped it to negative. Sure, that's fun. Now, this only does ones. Right, so some other things we can do. It's not really a unary operator. This is called a combined assignment operator. We could say value equals value plus 5 to add 5 to it. But now I had to type the word value twice, and I'm lazy. I don't want to have to type out something twice, or even like autocomplete it twice. So the combined assignment operator says value plus equals 5. It says add to it and then assign. Now the weird thing here is that equals plus 5 is actually legitimate Java code, but it doesn't do the right thing. What happens here is it says, oh, you want positive 5. Okay, value is now equal to positive 5. So be careful with these. The operator has to come first, and then the assignment here. So this will set to positive 5. So just be careful with that, right? You want to add 5 and then assign. So changing the value of something is so common. We have all of these combined assignment operators. You can plus equals, you can minus equals, you can times equals, you can divide equals, and you can even modulus equals if you want. They're all just shortcuts, right? So it does the exact same thing. This is same as above, but less typing. Yay. Right? Now, generally, just because we're saving typing doesn't always mean it's a good thing, but this is super common. You're going to see this all the time. So just get used to the syntax. It's not too crazy. We see, hey, plus equals, we're going to add to it and then assign. Generally, you can follow the flow of it here. It's not some crazy looking syntax. It just is going to take some practice. So nothing wrong with using the long form, but this one's faster. Okay. So in your code, if you use long form, it doesn't matter at all. I might make fun of you, be like, hey, you could have done this faster, just if I was feeling like pointing it out, but it will still get the job done, right? They're equivalent. So it doesn't matter which one you use. But again, good programmers are lazy. We're going to do it the shorter way if we can help it. Right? Those are combined assignment operators. And you can do that with addition, subtraction, multiplication, division, and modulus. So any of them are all there. Do we talk about order of operation? And I went on my big rant about how people on Facebook are terrible at math, which none of you guys folks see because you don't use Facebook because it's not cool anymore. It's for old people like me. Like when people argue about, hey, no one can solve this math problem. Okay. I talked about that before in order of operations. I'm getting a couple funny looks. Okay. I'll talk about it again. You can just ignore me if I'm ranting and it's obnoxious. But when people say, what is it, 90% of people can't solve this, percent of people can't solve this, ha 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 ha. So they'd say something like, hey, it's 5 plus 10 divided by 5 times 20 minus 10, or something like that, right? And they say, hey, don't use a calculator, do it in your head. Order of operations, right, is parentheses, exponents, multiplication, division, addition, subtraction. Remember, you learned PEMDAS, or please excuse my dear Aunt Sally. Right? Do they still say that in school? Okay, we still have Aunt Sally's. So all the parentheses first, all the exponents. Now the problem here is you have to say something first. Right? You can't say multiplication, division. It's not one word. But multiplication and division have the same order of precedence, the same level of precedence. So they operate from left to right, right? We know this because we do addition and subtraction that way. If I say, hey, what is my result is 5 minus 10 plus 20. Nobody says, oh, that's 10 plus 20 is 30. 5 minus 30 is negative 25. Nobody does that. So we understand how this works with addition and subtraction. We do it from left to right. 5 minus 10, negative 5, plus 20, 15, right? Same thing with addition or with multiplication and division. Just because you say multiplication first doesn't mean multiplication happens first, right? You do multiplication and division from left to right. So 10 divided by 5 is 2. 2 times 20 is 40. 5 times 5 plus 40, 45, minus 10, 35. Right? Okay. I don't know why this is so hard. I think just because people tend to hate math and they just ignore all the things that happen in math class. They just do their worksheets and get through it. But order of operations. Okay? Make sense? And modulus is the same level of precedence as multiplication and division. It's a division operation. It just gives you the integer result rather than the, is it the quotient? I think that's our math term for the math result number. We should get Mr. Tim. He has a master's in math and is really good. He would tell me what the right math term is. But he hangs out in the Tuesday night class. But have you folks been to study group, by the way? Tuesdays and Thursdays, 1 to 2?
I've been here yesterday for the first time.
Awesome, awesome. So super glad we get a chance to have Mr. Tim come along for study group, the group tutor time, essentially. So take advantage of that. You get an extra point on your weekly quizzes just for going. Like that's my incentive to get people to go. Again, if you, I'm sorry?
He didn't take my attendance. I don't know if he did, but it was just...
He usually does. He sends me an email every week with who's come. Yeah, so I'll add the extra points in at the end. I don't usually add them in every quiz. Like I wait till the end of the semester to add them in because otherwise it's just a bunch of work every time. And I'd rather just do it once. So order of operations, right, still applies in Java. We know how to do this. If you want something to happen first, right, if you want to do 5 times 20, put in some parentheses. That will happen first. Now remember, in Java, weird stuff happens with integers. So 5 times 20 is 100. 10 divided by 100 is 0. And integer division is 0. So 5 plus 0 minus 10, we get negative 5. Right? There's no decimals here because it's integer division. So just be careful with that as well. All right, cool. So we got about halfway through the chapter. I got to go drink some Coke or some coffee real quick. My throat's real dry. We'll have the rest of today to practice some of this stuff. You could get working on Project 3 if you haven't gotten a good handle on that one yet. No, Project 1. Sorry. We're doing Chapter 3. Numbers are hard, friends. Numbers are hard. So the project is due 2 weeks from last Monday. That puts us out at September 27th. I love giving 2 weeks for things so people have time. What tends to happen is people say, oh, I have lots of time. I don't have to start it. Okay? I'm happy to help you with it. But given that it's due on a Monday, if you wait until the weekend before it's due to start it, I'm probably not going to have a chance to meet with you. Right? I'm happy to try and do weekend appointments if you need it. Usually it's after my kids go to bed. But if everyone does that, then I'm going to have a chance to meet with 1 or 2 of you. And the rest of you, I'm going to say, I'm sorry, I'm busy. And then you're going to be mad at me because Eric didn't help you with it and he said he's going to help you. So please plan ahead. And then I do have my regular office hours. Did I mention those? So I looked at the when to meet that everybody filled out. And I'm going to hit the most amount of people that I could, scheduling blocks. Again, I wasn't going to schedule over dinner time. And a lot of people filled out dinner time. Like 6 to 9 was a good time for them most of the weekdays. And I ignored that because I'm eating dinner. So Tuesdays and Thursdays from 8 to 9. Seem to work pretty well for most people. And then Wednesdays, 2 to 5 in the afternoon. I can also meet after class. Mondays I can hang out after class. Wednesdays I can hang out after class as well, if that works for you. So feel free to book an appointment with me. I'm usually around. If you just shoot me a message, I'll be at my desk. But I might be meeting with someone else who did book an appointment. So check with me first if you want. Shoot me a message. Or by appointment if those times don't work. Okay? Did you have a question?
Yeah. So on the rubric for Project 1.
Yeah.
I don't know if this is just for me, but one of the criteria is showing the simply criterion.
Oh, really? Shoot. Let me see.
It might just be
Probably not. I probably screwed something up in D2L. It's supposed to like auto-save rubrics. Yeah, out of 8 points. So ask for their username. Username is used in the prompts. Ask how many guests. Ask how many slices of pie. Ask what kind of pie. New criteria. All right, that should not be there. Let me go fix that. Thank you.
What's supposed to be there instead?
It calculates the correct number of pies.
Oh, okay.
So if you don't round, you can still get a point for calculating the right number, and then rounding was a separate point. Let me go fix that. Thank you. Hydration, Michael. Thank you for redeeming the hydration. I actually can't drink here in class. I should probably turn off some of those silly channel point rewards. I'll go out and drink my coffee, though. All right, let me fix that.
I think we're still owed a bunch here.
Oh, yes.
I saw someone steal one
Did
of
someone
those.
redeem a dad joke? Oh, man, how did I miss that? I love dad jokes. All right, while I fix the rubric, let me pull this up here.
What kind of band something that's really important, so we have to work around it every time it's practice.
So, when my wife and I would like to pick out names for our kids, and unfortunately, or fortunately, it's kind of cool, all of the kids have J names. So, like, a bunch of names were out of the list because her grandfather's name was Jim. All of his kids had J names. All of her cousins have J names. So, and all of our kids have J names. So, like, it's a family tradition, which is kind of cool. But I really wanted to name a kid Lance. And she said, oh, no, that's not, that's really uncommon. Lance that's not really a great name. But I told her, well, in medieval times, people were called Lance a lot. All right, so the program calculates the number of pies. Oh, no, it is a whole number. What kind of pie have we made? Did I have an extra one? I did have an extra. Okay, that one's just extra there then. So we don't want that. Can I delete it? My goodness. I can't delete, really? Aha, delete row. There we, oh, you know what? I did have one more. That's what it was. So you get one more point while submitting the feedback pull request URL. So giving me the right URL. Some people when they did project 1, they gave me just the repository URL. That's fine, but then I have to click more places to see your code. So please make me do the least amount of work. Save me the time. And again, just get into the habit of using that feedback pull request, because then I'm right there where I can leave comments in your code. So you get a point just for doing that. That's what that last one should have been. That's what it was. So it's still 8 points, because it did have the rest of those calculate the numbers here. All right, I'll end the stream. I'm going to go out and grab some coffee. We got the rest of today to hang out, work on our assignments. I can hang out for a while after as well. We can practice things. There is another class coming in. Actually, not at 1, because Miss Osmi is running a little late today. She has to go to a funeral, unfortunately. So her class isn't coming until 2. But they might come here at 1 anyway, because they usually come here at 1. So I don't know if they're going to pay attention to the sign or not, or if she emailed them or whatnot. So we can hang out probably till 1 if we need to. All right?
There's free food or something?
Yes. Yeah, where's that food? So people on the Twitch stream, you're probably not coming to campus for food, so I'll see you later. Let me know what I can do to help. Take care, Michael.